Hello, which I can't believe I'm doing this. Like in, this is May June 2021. I think the second variant's pre-release material, and we'll do task one. So I have annotated some major parts of this task. So it says write a program to set up the screen display. That means screen display is one of our primary tasks for the day. Initialize suitable data structures to total passengers for each journey and total the money taken. So basically, the two data structures that they have specifically asked us to make are the total passengers and the total money taken. And each train journey must be totaled separately. There are four journeys up and four journeys down every day. So until now, we do know that we have to set up two data structures, which are again which I'll show later on, the one for total passengers and one for the total money taken for each train journey. But along with that, we also need to have a screen display, and this is the point where majority of the solutions that I previously saw on YouTube, they missed most of these things out. So the for the screen display, we need three essential components, which is in the second paragraph, I think, of the pre-release material. First are the train times. Second is the number of tickets still available. This is different from the number of tickets occupied. It is different from this. The total passengers from the journey is completely different from the number of tickets still available for each train. Every time a ticket is booked, the display is updated. When a train is full, the word closed is displayed instead of the number of tickets available. So this part, the closed part, that is something which can be covered in task 2 or 3, but not task 3, actually only in task 2. But just to stay on the safe side, I have covered that in task 1 as well. So if they ask you to write task 1 in the exam, it's preferable to write this code because obviously they won't cut your marks. There is no negative marking in CIs, so just to stay on the safe side, it is better to do it this way. Plus, the only way we can do it in class 2 is something is actually including a string in the array, which usually has integers, which usually had integers previously, which is again, I don't think it works. I asked a couple of people, and it doesn't work in real life, so it's better to do it this way. So yeah, the screen display has three essential components. Number one, train times. Number two, tickets still available, and that is different from this. That means we need to have two separate data structures, arrays, which we'll use in this case. One for the total passengers. For example, if 300 passengers are traveling from in a train which has the capacity of 480, that means the total passengers are 300 and the number of tickets still available would be 180. And the train times are again taken from this. I hope everyone has read the task previously, so we can cover everything right now without going back and forth with the pre-release material. So yeah, now coming go towards the solutions. So this is probably the simplest possible solution I could um, make up, because I went through a lot of material that is present on YouTube, and almost each one of them had a lot of mistakes. And after reviewing all of those secondary data or the solutions, this is probably the easiest, simplest, and the one which is, just to stay on the safe side, it's the best possible solution that we can have at this point. So first of all, a major thing that almost every other solution missed was this array, up passengers. The total passengers that are traveling. Again, this is to be used in future tasks, and if you do not have this in task one, it will definitely complicate things later on, and they have specifically asked for it. That means if you don't include this, your marks will be deducted. But apart from that, let's start from the first line. We are declaring a constant. You can do this in task 2 as well. It isn't necessary declaring the ticket cost, but this portion, if they ask you to write down task 1, this is probably where you'll get half of your marks from. So I have divided those 8 journeys into up and down. So the uptime, so first of all, this is an array. We are declaring an array. An array is a one-dimensional table and it is indexed. That means um, it has four separate rows, and if I want to call or find or read or simply print something that is in row three, I'll simply add I'll simply write down the name of the array, and in the brackets I'll write down the row number. In this case, 900, we can obviously assume that this is the first row, second row, third row, fourth row, and we are including these in inverted commas because they are again strings. These are not integers, they are not numbers, they are, this is time, it is called a string, and we always need actually inverted commas for strings. So yeah, uptime, we know that trains move up at 9 o'clock, 11 o'clock, 13:00, 15:00. And what does this portion mean? It simply defines the dimensions for the array. That means it has one column and it has one column and four rows. So after that, up, the divisions, yes, we have divided it in up and down. So everything that is for up will be for down except this, which I'll come to later on. So these are the times, those four journeys. These are the up seats available. That means uh, seats that are available for the journeys that are going up. All of them are 480. These are the total seats that are not occupied yet, but these are available at the start of the day when no ticket has been purchased. These are the up passengers. These are all the tickets, all the seats that have been occupied. And again, this is the start of the day. None of them have been occupied. This is why these are 000. Now, up money. They also told us that we had to define a data structure which has all the money collected for each train journey. So for all those journeys going up, it the for all those journeys going up, the money is at this point in time 000. So let's look back at what data structures we needed. We needed total passengers, which we have again defined in these up passengers. We needed the total money taken, which we have defined in up money. You can use different variables. It's completely up to you if you prefer to use simpler ones, but do keep in mind that they need to be meaningful. Yeah, and apart from that, we needed to have a data structure for the tickets still available. That means the total number of tickets, which is, yeah, these 480, 480, 480. And finally, we needed to have those train times. Now, all of these have been replicated for journeys coming down as well, and these are the times, but there's one main difference. Um, they told us in the description that the last train which comes back from the top has two extra coaches, and since each coach has 80 passengers, we'll have 160 more seats than usual. So this is why the last train journey has 640. Apart from that, everything else is same. So now we just have to display on a large screen all of this data. Not actually all of this data, but the train times and the number of tickets still available. So at this point, I need to clarify one major thing. I saw a couple of solutions, actually a lot of solutions, yeah, probably a lot, which used the train time as a primary key. So what do I mean by a primary key? It simply means, um, how do we actually identify a train with a unique characteristic? We did it in this task, which is way simpler than what our other solutions have done, and will help you a lot in the tasks later on, and keeps things very, very simple. We have numbered up journeys going up, that means departures from 1 to 4, and we have indexed return journeys, that means those journeys coming from the top to the foot from 1 to 4 as well. So for example, if I need if I want to go from in the third journey, I want to go up, that means from the foot to the top. It means I'll have to get the train of 1300, 13 o'clock, I don't know how to say it, but yeah, I'll have to get this train, and this will take me up. So yeah, so how do we actually print or display everything? First of all, we'll print the heading, departures going up from foot to top. मैं भी नहीं आ सकता. नहीं, जाओ अभी. नहीं था अभी. आज आ जाएगा, जाओ अभी. Yeah. So first of all, we'll print the heading, departures from the foot to top. After that, we'll print column headings. That means after the first row, we'll have a second row which has train number as our first column, time as our second column, and available seats as our third column. So below that, we'll use a for loop. So what do we actually use a for loop for? In the context of arrays, what a for loop does is it simply prints out every possible value if this value, that means when the for loop ends, is equal to the number of rows in the array. That means if I want to print the entire array of, for example, time, I'll simply put for count 1 to 4. That means it will run 4 times, and the text inside would simply say print uptime, and in our brackets I'll have count. That means after each iteration, count will increase from 1, then 2, then 3, then 4, and every time the next time the next journey time would be printed. So yeah, so when for count 1 to 4, that means it will run 4 times. If up seats available, count and in the brackets count is equals to 0, then print count the time and close. So what do I mean by this? This part. This is basically related to the part with this one, the yellow part, that we need to display closed instead of the number of tickets available when the seats available are 0. That means this is why we have used if up seats available of the current iteration is 0, then we'll print count. That means under train number we'll print count is basically the journey number. For example, let's assume that in our second journey, seats available have been reduced to 0. So print and count would be 2, uptime would be um, uh, I think 11, and in place of the seats available, that means under the available seats heading, it will simply display closed. Else it would print count, which is probably what we are going to use on most occasions when when there are seats available. It will display the count, that means the journey number, then the time, and then the seats available. And again, they are being recalled from here, these parts. The down seats available, up seats available, this is the time, and count is simply the journey number, the way we have indexed times. This may sound tricky at first, but again, it's really easy to understand. And we have done the exact same thing for journeys which return the top from top to foot. So it will display the heading return top to foot, then it will display again the same way we displayed over here, the headings in the second row, then again the same condition if down seats available, or that means the seats that are left are equal to 0, that means none are left, then it will print the journey number, then the journey time, and then it will simply display closed instead of the available seats that were to be displayed if the seats were available. Else, that means if this condition isn't true, that means if some seats are available, it will simply display the journey number, the time, and after that, those seats available. And in the end, the next count, that means the for loop has ended. And if someone noticed, I've written this down. If they're asked to write down task one only, then you should write this code. So basically, when I went through a lot of solutions, went through the pre-release material repeatedly, I understood that just to stay on the safe side, we need to have this. Otherwise, we can simply, when those seats available, for example, for the third journey down is reduced to zero. Wait a second. Yeah. So when the down seats, when this basically when return journeys, the third journey is reduced to zero, at, at that point in time, we can declare down seats available, and instead of 480, we can simply redefine it as closed in place of it. That is another method, but we can do it in task 2. But again, just to stay on the safe side, I think they expect us to do it in the first task. Most of the solutions don't have it here, and the way they have done it in the task 2 is mostly incorrect. So just to stay on the safe side, Cambridge won't negatively mark you. You won't, your marks won't be cut for this. Just to stay on the safe side, do this. Use an if condition. This is the best possible solution that we have. Just to stay on the safe side, you'll definitely get 5 marks or 4 marks if you're asked for it. So this is the second version of task one. I don't recommend it. You should do it if they ask you to write down task 2 along with task 1 as well, or something along those lines. But it has all of those exact same things, but the only difference is we aren't using those if conditions that I uh, told you about beforehand. So in place of those for loops, or in place of those if conditions, in the for loop we simply have journey number, the time, and seats available. Some solutions also made the mistake of displaying money collected as well, but if you look clearly, they haven't asked you to display they haven't asked you to display total passengers or the total money taken. So they are just to be stored as a data structure. They aren't to be displayed on the screen. The screen display only requires train times, tickets available, and to a certain extent, simply a condition of seats of displaying closed instead of zero when there are no tickets available for the respective journey. So yeah, I think this is pretty much it. If there are any questions, yeah, please don't ask. This is probably the best solution you're going to get. Work with this.